So the next part, we're still on 2.2 of circles. So now we have two equations for a circle. This one is called the general form. And, well, it's not very exciting because it doesn't really help you very much with things, okay? The center radius form I like because you can see the center by looking here, and you can see the radius. So that's why it's called the center radius form. So if we're given the general form, we want to convert it and change it to the center radius form. So, step one. When we're given this, we're going to organize the terms so all the x's are together and then all the y's are together. Then we're going to move this constant term here. The constant term is the one that has no x or y. Okay? We're going to move that to the other side of the equation. And then we have to do that thing called completing the square. And we're going to complete the square for the x's, and then we're going to complete the square for the y's. And then you're done. It's in center radius form, and you can just take out the center and the radius and graph it if you want. So let's do some examples. These are some examples you can look at on your own, okay? But let's look at this. So first, I'm given this standard form equation for a circle, and I go, okay, so I'm just going to copy it out. That's my first step, really, is just copy it out. So now what we want to do is we want to put all, oops, that has an x here. We want to put all the x's together, and then we put the y's together. But stop. Put a line afterwards, a space. We're going to put something here. Then we're going to do the y's. Stop, put a space. Now we're going to take this constant term and put it on the other side. So if I move that to the other side, I change the sign. Or I can just go plus 1, that's gone, and I have a 1. Okay, but that constant term needs to go to the other side. So now we're going to complete the square. And if you were here last semester, we did completing of the square. If you weren't, it's not that hard. All you do is you take whatever this value is in front of the x, not the x squared one, the one that has just a 1 in front here, exponent 1 that's hiding. So you take this, you always divide it by 2, and then you square it. So whatever number is here, you divide by 2, then square it. And that's equal to 2 squared, which is equal to 4. So now I'm going to add a 4 here. So what that does is I have this equation that I want to factor. And now it's like a perfect trinomial, and I can factor it nice and easy. So now we're going to do the same thing for the y's. Halaweli, I don't care about the negative or positive. I just take the number. So I take my 4, I divide by 2, and then I square it. It's always the same. Whatever that number is, divide by 2 and square it. So that's 2 squared equals 4. It's the same thing. Uh-oh. But I went too fast. So here, because this is like a mizan, a scale, if I add 4 to this side, say it's like, the teeter-totters that children sit on. If I put 4 kilograms extra on this side, it's going to go down here. And this little kid's in the air going, help me. So what I need to do is if I add 4 here, 4 kilos here, I have to add 4 kilos to this side. And that keeps it nice and even. Okay? So now, to finish this, I have a 4, so I'm going to add 4 here. But again, if I add 4 kilos this side, I must add 4 kilos to this side to keep it equal. Okay? So now, I need a little piece of paper. I'm going to cover this and cover this. So now I have this equation that I want to just factor nice. And because it's a perfect trinomial, I just take the square root of this, which is x, the square root of this, which is 2, And whatever sign this is, I put here. And I've just factored it. And it's easy to factor because it's a perfect trinomial. So now I'm going to do the y's. Okay, so square root of this, square root of this. Because that's a minus, I put a minus here. That's it. And then here, add all that up, and I go, oh, that's 9. Look, it's in the circle radius form of the equation for a circle radius. So if I want the center of the circle, I just take these. I go, oh, 2, 2, that's my center. But be careful. You can't just take the numbers. You always have to take the opposite sign. So if this is plus 2, it must be a minus 2. And if this is a minus 2, this one has to be a plus 2. Now to get my radius, I just take the square root of this. And I go, oh, my radius equals 3. So this form is so much nicer because you can get the center out of it. You can see the center and you can see the radius. Whereas here in standard form, blah. Okay, so now we can graph it. So the center is negative 2, 2. My radius is 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And then I pretend to draw a circle. There. Okay, so let's do another example. It says, convert the equation to center radius form and then graph it. So you see this and you go, oh, I don't know how to graph it from here. I can't. I need to put it in center radius form first so I can find the center and I can find the radius and then I can graph it. So first I just copy it out. Now I put all my x's together, and then a space, then my y's together, and a space, and this constant term goes to the other side, but if you move it to the other side, it becomes the opposite sign, so it's 12. So now we need to complete the square. So I take this number, I divide it by 2, and I square it. So that's 3 squared equals 9. So now, to make this a nice perfect trinomial, I have to put a 9 here. But if I put a 9 on this side of the equation, I have to put a 9 on that side of the equation. So now I'm going to do the y's. Whatever is here, I divide it by 2, I square it. So that's 2 squared equals 4. So now, to make it a perfect trinomial, I put a plus 4 here and a plus 4 here. So now, I just look at this and I want to factor it. But because it's a perfect trinomial, I just take the square root of this, x. The square root of this, 3. And then I go, oh, it's minus. I factored it. And I'm going to do the same for this one. Square root of this, square root of this. Whatever is there, put it in, the sign. And then I have to add all that up, which is 25. And now look, it's in center radius form. So if I want to graph it, I can go, oh, here's my center, 3, 2. Is it 3, 2? I have to take the opposite signs, negative, positive, negative, positive. Yep, 3, 2, that's my center. And now my radius, I have to take the square root of 25, which is 5. So my radius is 5. So now I can graph it. So 3, 2, 1, 2, 3, 1, 2. Radius is 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So now I just sort of draw. There's my circle. It's not pretty, but you get the idea. Okay, let's do the next one. So, graph the equation. So this time it doesn't say put it into center radius form. But you know, when you look at this, you go, what? Where's the center? Where's the radius? You don't know. So you have to put it, you have to know to put it into center radius form. So I just copy it out. Move all the x's together. Put a space. Y's together. Put a space. And move the constant term to the other side. And when you move him to the other side, he becomes the opposite sign. So now you have to complete the square. You take this number, divide by 2, square it. So that's 1 squared, which equals 1. So now I have to add 1 to this side and this side. Don't forget to do both. So now I'm going to complete the square for here, for the y's. So whatever that is, I divide by 2 and square it. So now, to complete the square here, I have to add 4 and add 4. Always to both sides. So now, I'm going to factor this. But because it's a perfect trinomial, take the square root of this, the square root of, what's the square root of 1? Just 1. And that's a minus, so it's a minus. That's it. Now I'm going to do the y's. Let's cover up everything else. You don't want to see everything. Too confusing. So there is my nice equation. Take the square root of this, the square root of this, because it's minus. There, I factored it. That's why we put it as a perfect trinomial, because it's easy to factor. And then this is 9. So now this is in the center radius form. So here is my center, 1 and 2. But be careful, if this is negative, this must be positive. This is negative, it must be positive. Okay, that's my center. And my radius, I take the square root of 9. So my radius is going to be 3. Now I can draw it, because this is in a nice form. I like this form. If I liked equations, I would like this form. So the center is 1, 2. My radius is 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Oh, I counted wrong on that one. I have to start here. 1, 2, 3. So then I draw my circle. There.